Yeah, whoever thoroughly prepared this particular subject, so you people can check your confidence and knowledge regarding this particular subject, whether your preparation is up to level or not, or whether you have to do further revision, etc. All of you can kindly cross check with the help of whatever the questions that we are going to discuss in this particular session, right? Okay. And this is our Telegram channel. So whoever not yet joined our channel, so all of you can kindly join. The link is provided in the description of this particular video. So all these updates you will be getting in our Telegram channel. It is free for everyone. Okay. Yeah. So I hope all of you are eagerly waiting for the session. So let us start. So regarding this particular subject, digital circuits, total we are having 7 chapters. Okay. Total we are having 7 chapters, out of which with respect to branch wise you can have observation here. All the 7 chapters are part of the GATE syllabus for EC and instrumentation, whereas for electrical branch the syllabus is up to 6th chapter, whereas for computer science the syllabus is up to 5th chapter. Okay, so with respect to weightage wise I have mentioned here, right? So in today's session we are going to focus the questions regarding first 3 chapters, like chapter 1 number system and codes, chapter 2 Boolean algebra and K-maps, chapter 3 logic gates. Okay, these 3 chapters related most of the important and most important concept related questions, and which are expected models for your coming GATE exam, that we are going to cover in this particular session. And tomorrow we will be discussing all the expected questions and most important and important concept based questions we will be covering regarding remaining 4 chapters on tomorrow's session. Okay, right. Yeah, now we are going to start the first chapter questions, that is number systems and codes. Okay. Yeah. So this is the first question. All of you can give a try. I will be giving time for every question. All of you can give a try. After that, I will be discussing regarding the solution part. Okay. All of you can kindly actively participate, and then you can check your confidence and knowledge in this particular session regarding the subject digital circuits. Yeah, I am giving 1 minute time. All of you can give a try. Yeah, whatever the answer you are getting, you can mention in the chart. Okay, I will confirm whether your answer is correct or not in some time. Okay, so in this particular question, if you observe, the question type is very important. Whenever the question is of MSQ, so I clearly mentioned there, so either one option or more than one option can be correct. Okay, so for MSQ, either one option or more than one option can be correct. So whichever correct options are there, you have to select accordingly. Okay, then only you will be getting marks assigned for that particular question in the GATE exam. Okay, right. So this is the question, like you just observe addition of 2 numbers, 2, 4 and 1, 3. 2, 4 and 1, 3 both belong to base 5. Both belong to base 5. You have to perform addition, and here if you observe choices, 2 options are there in decimal, 2 options are there in base 5. So here for this particular question, among base 5 numbers, whatever 2 choices, among that, just by observation, at most among these 2 choices 1 can be correct, at most 1 can be correct, and similarly among A and D at most 1 can be correct. Yeah, just mention your name. You got one correct option. You got one correct option. So one more correct option is there that you closely observe and guess. Okay. Just mention your name so that I will pronounce accordingly. Okay. Right. So here 2, 4 and 1, 3. 2, 4 and 1, 3 both belongs to base 5. 2, 4 and 1, 3 both belongs to base 5. You have to perform the addition, right? So now you perform just like normal addition. Okay, 4 plus 3 is what? 7. 4 plus 3 you are getting 7, but here base 5 number. Okay, so just I'm writing here 4 plus 3 you are getting 7. 7 you are getting in the decimal. Okay, but here we have to represent in base 5. Okay, so now this 7 what you can do? You can do here when you are having base 5 for a single digit, maximum value you can represent is 4 only, but it is exceeding maximum value of that particular number system capacity. Now you have to represent this number as base plus something. Here base is 5. Base is 5. By adding with which number you are getting resultant answer, that will be your sum digit. Okay, 5 plus 2. 5 plus 2. So in this case you are getting 1, 2 are the two digits belongs to base 5. So in this case 2 is the sum digit, 1 is the carry. Okay, 2 is the sum digit, 1 is the carry. So that means here you are getting sum digit as 2 and carry digit we got 1. We will be adding here. Now 1 plus 1 is 2, 2 plus 2 is 4. 4 you can represent in base 4, base 5. Okay, 2 we can represent in base 5. So that means 4 you can copy as this. So that means as of now we are getting option C, right? So option C is the correct one. As of now we are getting one correct option, that is option C. Now since the question is of MSQ, even though you got one correct choice, you have to observe remaining choice also. Among the remaining choices, which option, whether any other option also going to be correct or not, you have to cross check. Okay, so among B and C, as of now C is correct. Okay, right. Now among A and D we have to decide. Very simple. So here 4 to base 5 we got. 4 to base 5 we got. Now in order to represent in decimal, you will be considering positional weights in powers of corresponding base. Here base is 5, 5 power 0, 5 power 1. Okay, now 5 fours are 20. Okay, I am writing one step. 5 into 4 plus 5 power 0 is 1 into 2. So 5 fours are 20 plus 2, that is 22. Yes, 22 in the decimal number system. Yes, that is also correct. So that means option D is also correct. So for this question, two correct choices are there. Two correct choices. C and D. B won't be correct. B won't be correct. See, if you are having any doubt, okay, if you are having any doubt, then what you can do, see, one approach I have told here, another approach if you want, what you can do, you can convert these numbers into the decimal and you can perform decimal. After that decimal number you can convert into base 5. Then also you will be getting option C only. Option B won't be correct. Option B when it can be correct, if both the numbers are decimal and final answer in the decimal, then option A will be correct. Okay, so it is a trap. Option B is the trap. Option A is also trap for this question. Okay, for this question C and D are the correct choices. So here 4 plus 3 is 7 you got. This 7 when you convert into base 5 by doing repeated division, then also you will be getting same number 1, 2. Okay, I hope it is clear. Yeah, next question. So here I have given one relation. So you have to find out this relation will be true with respect to which number system. 3, 4 plus 1, 4 should be equal to 103. In order to make whole this equation, whatever the numbers are there, 3 numbers, these 3 numbers belongs to which number system? So whatever the concept just now we have discussed, you can apply same concept. With the help of that, you can easily decide the resultant base of the number system. Yeah, in this question, they have given one relation like this: 3, 4 plus 1, 4. 3, 4 plus 1, 4 should be equal to 103. Okay, now just perform the addition digit by digit. 4 plus 4, that is equal to 8. 4 plus 4, you are getting 8. But here 3 is there. Yes, very good, Jitsu, very good. So here 8 you are getting, but here you are having 3. Okay, so that means now what you can do, since here 3 is there, that you can copy. Now that 3, by adding with which number you are getting 8? 5. That's all. That is the base. See, in the earlier question, what we have done, forward approach, 4 plus 3. Because here base is given, 4 plus 3 is 7 you got. 7 you cannot represent in base 5. That's 5. Base plus something. Okay. Now, in this question, base not given, base we have to calculate. Okay. Now, resultant number you got 8 here. 8 and 3, both are not matching. That means you have considered whatever the sum digit they have given, by adding with which number you are getting 8. That is your base. That's all. Okay, so in this case, you are getting 2 digits, 1 and 3 belongs to base 5. Whether it is correct or not, you can easily verify. Just like here, whatever the concept we have discussed, exactly similar manner you can follow. 5 power 0, 1 second, yeah, 5 power 0, then 5 power 1. So 5 ones are 5 plus 3, that means 8 only, right? So in this case, 3 is the sum digit, 1 is the carry. Now you can add here, 1 plus 1 is 2, 2 plus 3 is 5. Okay, just for reference I am writing here, 3 plus 1 plus 1, that is 5. 5. Okay, so since we understood that it is a base 5, in base 5 number system we cannot represent digit 5. Okay, so that's why what we have to do here. Here, you just observe, sum digit 0 given, by adding with 5 only you are getting this one. That means you require 2 digits here. 1 0 belongs to base 5. Here 0 is a sum digit, 1 is the carry. That's all. So here 0 is a sum digit, 1 is the carry. Yes. Now this relation holds good, provided if the given numbers, all the 3 numbers belongs to base 5. Okay, answer for this question is 5. Yes, very good, Jits. Yeah, next question. So in this particular question, you are having one relation like this. Okay, in this question, all the numbers belongs to same base, that is x. Okay, so first of all, you have to find out what is that base value, and after that, for this particular number 3 to 3, whatever the base you are getting, accordingly you will be considering respective base. Now for that number, when you convert into equivalent binary, in that equivalent binary, how many bits are required? That is the question. How many bits are required? First of all, give a try regarding this particular equation. What is x value? If you are able to get x value correct, After that, you can easily proceed further. First of all, try to find out the base value x. See here, just by observation, like here digit 5 is there, 5 and then 4. When you are adding, you are getting 9. But here you are getting, as per the given equation, they have given 3. Okay, both are not matching. That means now you have to do adjustment. So since some digit has given 3, by adding with whichever number you are getting 9, that is the base, that's all, 6. So in this particular question, you are getting x value as 6. X value as 6. Okay. So just for reference, I am mentioning 1 is the carry digit, 3 is the sum digit. Okay, I am not doing continuation further. If you want, you can give a try later. Whatever the approach we have discussed earlier, accordingly you can give a try. You will be getting resultant answer like this. Okay, right. Now we understood that resultant base is going to be 6. Okay, resultant base is going to be 6. Now the question is, for 3 to 3, when you consider into base 6, 3 to 3 base 6. Now convert into decimal by putting the positional weights in powers of 6. 6 power 0, 6 power 1, 6 square. 6 square is 36 into 3 plus 6 power 1 is 6 into 2 plus 6 power 0 is 1 into 3. Okay, so just perform the addition. 108 plus 12 plus 3. 108 plus 12, that is 120 plus 3, that is 123. Right? 123 you are getting in the decimal. 123 is the decimal. Now for this decimal number, how many bits are required? That is the question. All of you give it a try. How many bits required? 7 bits or 8 bits? 7 bits are sufficient. Yes, sir. For representing 123 in decimal, 7 bits are sufficient. Because when you are having 7 bits, you will be getting range as what? 0 to 2 power 7, that is 128 minus 1, that means 127. 0 to 127, 128 possible values you can represent with the help of 7 bits. So 123 is falling in this particular range, right? So that means 7 bits are required. Okay, I hope it is clear for everyone. Now the next question, very interesting one. Very interesting question. Here in this question, you are having one relation or equation like this. In this particular equation, after doing the simplification, whatever the number you are getting, definitely you will be getting decimal. When you convert that decimal into binary, in that binary number, how many ones you are having? That is the question. How many ones you are having? That is the question. Okay. In general, if you follow like that, then definitely it will take more time. Of course, you will get definitely correct answer. There is no doubt in it. But whenever you are coming across such kind of questions, just have a close observation. Whatever the multiplication factors they have given, definitely it will be powers of some number. If you are getting like that, then try to apply whatever the inherent logic that has given. Okay. Now, if you rearrange this equation, for the timing, if you observe, this is one term, second term, third term, fourth term, right? Among the four terms here, two numbers are having positive sign, two numbers are having negative sign. That means just keep the given numbers like positive numbers one side, negative numbers other side. Okay. Then what we can do, very simple, like 5 into 4096 is there, that we can write it as 16 power 3. Direct step I am writing. You can verify. 16 square is nothing but 256. Multiply with 16, you will be getting 4096. Okay. Then yeah. Then here you are having one number. Okay. This number I will write after some time. Then I am writing this number. 8 into 16 power 1. Okay. So that means, okay, I am just rearranging like this. So since 16 square term with respect to positive number is not there, so I am multiplying with 0. 0 into 16 square. Now plus 8 into 16 power 1. Then with respect to positive sign, we don't have one more number, so that's why I'm keeping digit as 0 into 16 power 0. See, just you can closely observe, 5 into 406, yes, that term is there. Then 8 into 16, that term is there. Other two terms not there. But here I have introduced, because overall you are getting like 16 power 0, 16 power 1, 16 square, 16 cube, like that. So just by observation, so whichever positional weights with respect to positive numbers are not there, regarding respect to digits I have considered 0. When you are multiplying 0 with any positional weight, definitely you are getting 0. When you are adding 0 to any number, resultant answer will remain same. Okay, right. Now this much you understood. Now minus I am taking common from the second term and last term. From second and last I am taking minus as common, right? Then here you are having 2 only. That means I can write here as 2 into 16 power 0. Yes, I can write. Fine. 16 power 0 is nothing but 1. 1 into 2 is 2. Correct. Then here regarding 16 power 1, you can consider digit as 0. 0 into 16 power 1. Right. Now 256 you can write as 16 square. Now digit is 7. Right. Then 16 cube, minus sign term is not there, so you can consider digit as 0. 0 into 16 cube. This is the observation you are getting just by observing this particular equation. Okay, right? So here with respect to negative terms, 2 terms are there. When you took minus common, then 7 into 256, then 2 into 16 power 0 is 1. Now other 2 digits I have considered simply 0. So just by observing here, what you are getting conclusion point, very simple. Whatever the given equation is there, it is actually subtraction of 2 hexadecimal numbers, right? Subtraction of 2 hexadecimal numbers. Now you can write the corresponding numbers like this. Yeah. So here first hexadecimal number you are getting 5080 base 16. 5080. Okay, that is one hexadecimal number. Now second number is what? 0702. 0702. Right? 5080, then 0702. Okay. Now just perform hexadecimal subtraction. Just perform hexadecimal subtraction. Right. Now just like normal decimal only, but only the difference here base value 16. Whenever you require borrow from the next higher digit, accordingly you have to add corresponding base. That's all. Now 0 minus 2, not possible. So we require borrow from the next higher digit. We have to take borrow from the next higher digit. Since these numbers belongs to base 16, now when you are taking 0 minus 2, not possible, right? So now you have to take 1 from here. That means here, that is nothing but base. That is nothing but base. Okay. 16 plus 0 is what? 16. Now 16 minus 2, yes, it is possible. 16 minus 2, it is possible. Okay. 16 minus 2 is nothing but 14. 14 is nothing but E. See, simple logic. When you perform addition of these two numbers, E is 14 plus 2, that is nothing but 16. 16 is the decimal number. If you want to represent in base 16, you cannot represent 16 as a digit in base 16. That time 16 plus something. 16 is what? Base plus something. By adding with which number you are getting 16? 0 only. That means 0 is what? Some digit, 1 is the carry. So while you are performing addition operation, you may get carry. While you are performing subtraction, you may require borrow. Whenever you are subtracting, whenever you are supposed to subtract larger digit from smaller digit. Okay, I hope all of you understood up to this point. Up to here, everyone will be doing perfect. There is no doubt at all. But most of the time, generally students will forget subtracting 1 from where you took the borrow. Okay, since you took borrow from here, okay, you took borrow from here, so you have to subtract 1 from here. 8 minus 1 is nothing but what? 7. Now 7 minus 0 is possible. That is nothing but 7. Now 0 minus 7, not possible. Just like here, 0 minus 2, not possible. So you have to take borrow from here. Then equivalent value of borrow is nothing but base of the number system. That is nothing but 16. 16 plus 0 is 16. 16 minus 7, 9. 9 you can represent in base 16, right? Yeah, with the single digit. Fine. So since you took borrow from here, you have to subtract 1. 5 minus 1 is what? 4. 4 minus 0 is 4. 4, 9, 4, 9, 7. Yes. This is the hexadecimal number. Now what is the question? Whatever the overall expression is there, after doing the simplification, that number you have to convert into binary. In that binary, how many ones you are having? That is the question. Now you got hexadecimal number. You know how to represent each and every hexadecimal digit in terms of binary. Every digit you can represent with 4 bits. In that overall number, how many ones you have? That's all. See, for understanding purpose, I have written all these steps. But once if you know this concept very well, without writing this much, in one step you can write resultant numbers here, and then you can perform subtraction. After that, when you got hexadecimal number, you are very much familiar in order to convert every hexadecimal digit into the equivalent binary. Okay, so I'm not writing equivalent binary. Directly I'm writing how many ones you are getting in the equivalent binary. But I will tell for every digit, whatever here you are having, equivalent binary what you are getting. 4 is nothing but what? 0, 1, 0, 0. That means single 1 is there. Next. 9 is nothing but 1, 0, 0, 1, 2 ones. 7 is nothing but 0, 1, 1, 1, 3 ones. E is nothing but 1, 1, 1, 0, 3 ones. That means here 1 plus 2 is 3, 3 plus 3, 6, 6 plus 3, 9. 9 ones you are getting. 9 ones you are getting. Yeah, good evening everyone. Yeah, I hope all of you understood. So this is the question based on number system conversion and with respect to basic arithmetic operations. It is a combo of both the topics, right? Yeah, next question. All of you can give it a try. This is also MSQ type. See, whenever the question is MSQ, I clearly highlighted so that if the question is MCQ, the moment you are getting one correct choice, you don't need to verify remaining choices whether they are really correct or not. But for MSQ, you have to really verify. You have to verify even though you got one of the correct choice, but still you have to verify remaining choices. Among the remaining choices, which option can be correct? If at all, if it is present, you have to mark them. Yeah, one of your choice is correct, other choice you can cross check. Okay. So in this question, you're having one decimal number minus n. Yeah. The decimal number, negative decimal number minus n in the 2's complement representation. Here you're having one number 1011. That is already represented in 2's complement form. The wording is very, very important in any subject in the GATE exam. That is even more you have to pay attention with respect to digital circuit subject. Okay, the you're having one binary number 1011, it is already represented in 2's complement form. When it is already represented, that time you convert into decimal equivalent. So the moment whether you're having 2's complement, 1's complement or sign magnitude, just first and foremost you have to observe sign bit. The moment if sign bit is 1, it indicates net number. The moment if sign bit is 0, it indicates post number. That is the indication when the word representation is given. Okay, so here the sign bit is 1, that means you are getting negative. Fine. Since in this question they mentioned the number 1011 is already represented in 2's complement form, now you can place just like unsigned binary, you put the position weights in powers of 2. 2 power 0, 2 power 1, 2 square, 2 cube. After that, what extra you have to do? Very simple. If the sign bit is 0, you have to consider positive. That means resultant value you are getting post number. Since sign bit is 1, you have to consider respective position weight negative. That's all. That's all. Yes, very good, Jitsu. Very good. So here, wherever ones are there, just add respective position weights. Wherever ones are there, just add respective position weights. Minus 8 plus 2 plus 1. That means 2 plus 1 is 3. Minus 8 plus 3 is minus 5. That means from here what you are getting, n value is 5. N value is 5. Okay. So here you are getting n value is 5. Now the question is what? Minus of n plus 1. Minus of n plus 1, that means minus of 5 plus 1, that is minus 6. So minus 6, you are having one decimal number. Now this number you have to represent in 2's complement form. Now just now only I have told this logic. Now by using this logic, so since you are having 8 number, definitely corresponding position weight should be 1. Corresponding position weight should be negative, and the corresponding sign bit you have to consider 1. Right? This is the observation. That means here you are getting minus 8. Now by adding with which number you are getting minus 6? 2 only. Correct? Minus 8 plus 2. That means now minus 8. That means here sign bit will be 1. Then 2 you are getting this particular bit position weight. That means other 2 bits you can consider simply zeros. I hope. See, in this particular session and even tomorrow's session also, regarding digital circuit subject, I am not discussing any conventional approach. The reason is, by this time you might have learned all the conventional approaches. But wherever required, I am discussing all the shortcuts only, so that you can, whoever thoroughly prepared by this time, if you want to check your knowledge and when you are getting correct answer, definitely I am appreciating. And for any question if you are getting stuck, no problem. You are trying yourself initially. After that, when I am discussing the shortcut method or whatever the basic points I am touching, with the help of that you can update your knowledge. Definitely you can maximize your score in the upcoming GATE exam. Okay, right. Now 1010 you got, that is nothing but minus 6 in 2's complement form. Right? So 1010, that is there in option A. Option A it is there. Now that means option C we can eliminate, it won't be correct. Now option B, option D, among these two we have to decide. Now just observe 1010 is there. Here also 1010 is there. See, just have observation. 1010, whatever you got, that is there here, that is there here. Now whether B is going to be correct or D is going to be correct. This is a very, very interesting point. Here in option B, rightmost side 0 was appended, whereas in option D, leftmost side 1 is appended. Obviously, according to sign extension property. Okay, here when you're having 1010, sign bit is 1. The same sign bit you can append any number of times to the left of the sign bit, equivalent value won't change. That means option D is going to be the correct. So obviously option B won't be correct. So for this question, 2 correct choices are there, option A and option D. Actually for represent -6, 4 bits are sufficient, but in this question they asked that -n plus 1, minus of n plus 1 for this particular equivalent number in 2's current form. Among the 4 choices, whichever are equivalent, those choices you have to correct. Okay, right. I hope all of you got the clarity. In this way, whenever you are solving any MSQ in the GATE exam, if the question you can solve in less time, if you felt like that, then definitely you can immediately attempt. But if you feel that, sir, it may require more time for me to solve, then definitely you can hold for second round or third round. Because MSQ, for MSQs, unless otherwise, whatever correct options are there, you are marking all the correct options, then you won't get partial marking. Okay, you won't get partial marking, right? If you want to get marks assigned for that question, whichever correct options are there, you have to mark all the correct options. Since there is a suspense and surprise for MSQ, whichever questions you can solve in less time, definitely touch in the first round, but whichever questions little bit twist or tricky, then you can keep hold for second round or third round. Okay. Yeah. Next question. Here in this question, A and B both are represented in 2's current form. Now subtraction of B from A. Subtraction of B from A you have to do. Okay, I am giving 1 minute time. All of you can give it. Yeah, just observe here. A and B both are represented in 2's current form. Fine. Subtraction of B from A. That means you have to perform A minus B only. Just observe here. Subtraction of B from A. That means A minus B you have to do. A minus B is nothing but A plus of minus B. Now, A as it is, minus B you are getting by applying 2's complement to B. By applying 2's complement to B, then you are getting minus. Okay. Now, so first of all, consider the B number. For that, you apply 2's complement. First, I am considering B number. B number is nothing but 0001, 0001, and then 4 zeros. 4 zeros. Okay. Just apply 2's complement to this number. Just apply 2's complement to this number. That is nothing but 2's complement of B. That is nothing but minus B. Okay. In short, I am writing here minus B. So by using two-step procedure, okay, start from right hand side, go towards left hand side till you are getting first time 1, copy all the bits as it is. Since you are getting first time bit value 1 from right to left, so you copy all the bits as it is, right? So that means 1 followed by 4 zeros, 1 followed by 4 zeros, right? That is the first step. Now after you complete first step, whatever the remaining bits are there, just you have to perform ones complement. So 000 is there, just apply ones complement, you are getting 111. This one approach. Another approach is what? You can perform ones complement and then you can add one. From there also you will be getting same answer. Okay, right. Now, so this is you got as of now 2's complement of B. Now, for this number, you have to add A. That's all. That's all. Now, A number you can copy as it is. 0011, 0011, then 0011. Just perform the addition. That's all. Okay. Now, just like unsigned binary, you can perform the addition. 0 plus 1 is 1. Here 1, then 0, then 0. Right? Okay. Then 1 plus 1 is what? Sum is 0, carry is 1. Then 1 plus 1, 2, 2 plus 1, 3. That means sum is 1, carry is 1. Sum is 1, carry is 1. 1 plus 1, sum is 0, carry is 1. 1 plus 1, sum is 0, carry is 1. Now just observe whatever the resultant number you got, whether overall number is the final answer or any modification. Or in other words, my question is very simple, whether leftmost side, whatever the one you got, whether I have to consider or not in the final equivalent answer. Yeah, just observe this very, very important note point. Whenever you are performing addition of two numbers, now just observe, A is one number, now 2's complement of B, that you got minus B, that is nothing but some other number like Y. A and Y you are adding, and both the numbers are represented in 2's complement form. Now, just have observation. Here sign bit is 1, that means what? It is an 8 number. Here sign bit is what? 0, that means positive number. Now just have observation. You are adding positive number with an 8 number. That means actually you are performing what? Subtraction, right? So whenever you are performing subtraction, you don't require extra bit. Rather, whatever the number of bits here, 8 you considered, the resultant answer in order to accommodate when you are performing subtraction, 8 bits are more than sufficient. So whenever, if sign bits are different here, if sign bits are different, if you are getting leftmost side carry, please ignore that. That won't, matlab you should not consider. But when you're adding two positive numbers or two negative numbers, that time we may require extra bit. But when you are adding positive number with negative number, that time, if at all, if you are getting leftmost side extra bit carry 1, ignore. That's all. Now, whatever the remaining bits you're having, that is the final answer. 0010, 0011. 0010, 0011. That means option B is the correct answer. This is a very, very interesting concept and interesting, important model also with respect to GATE exam. Generally, many of the students are having regular unsigned binary, how to perform addition and all. With the help of that, they will be doing up to here. But whether your final answer correct or not, based on the context of the given numbers, you have to cross verify, then accordingly you have to choose whichever correct option is there as per the concept, as per the context. I hope it is clear. Yeah, next question. I hope all of you can answer this question easily. This question is of MSQ type. Okay, I'm given time for everyone. All of you can give it. Yeah, Jitsu, regarding the previous one. Okay, see, Here you are adding negative number with positive number. Okay, just for information, I am giving with one example question. Later you can compare. Matlab, with the help of that understanding, you can apply the same process for this question in your free time. Okay, just I am discussing. Like let us consider two numbers like 1011, 1011. Okay, and another number is 0100, 0100. Now in this case, what you are getting, just perform the addition. You are getting 1 1 1 1. All the numbers are ones 1. Okay, this is one example I have considered. One more example I am considering, like 0101, then 1100, 1100. Now just perform addition. 1 0. Here sum is 0, carries 1. Here sum is 0, carries 1. Right. Okay, another two cases I am writing. Yeah. So just observe here, whatever the numbers I have considered. Okay. See, in all the four cases, I just performed the addition only. In all the four cases, I performed addition, just like earlier question. In all the four cases, I performed addition operation only. And just like earlier question, whatever the two numbers I considered, in every case, all the numbers are already represented in two-count form. Okay. When you know that those numbers are represented in two-count form, okay, now just for our understanding, convert into decimal equivalent. Right. So first have a observation. The moment sign bit 0, which indicates what? Positive number. Sign bit 0 means positive number. Then remaining bits give what? Magnitude. 101 is nothing but 5. Okay. Similarly here, 100 is nothing but 4. Okay. So that means 0101 is nothing but plus 5. Next, 0100 is nothing but plus 4. Correct? Next, if you observe, 1011 is that number is nothing but, for this number if you apply 2's complement, you will be getting. Okay, or in other words, here since the numbers are represented in 2's complement form, minus 8 plus 3 is nothing but what? Minus 5. Like that also you can get. Okay, 1011 is nothing but minus 5. Then 0100 is there. For this apply 2's complement, then you are getting 1100. Okay, then this number is nothing but minus 4. Right. So I hope up to here there is no doubt, right? I hope it is clear. Now in all the four cases, I am just adding the given two numbers. Now, whether the resultant answer is same or whether we have to do any adjustment, we have to observe. So here minus 5 when you're adding with plus 4, minus 5 when you're adding with plus 4, you are getting final answer as what? Minus 1. Yes. So here for representing minus 1, actually one digit is sufficient. Because the moment when you consider 1, the corresponding position weight is 2 power 0. Since sign bit is 1, then minus 2 power 0 is nothing but minus 1. Or by using sign extension property, whatever sign bit is there, the same sign bit you can place. You can extend any number of times to the left of the sign bit. Equivalent value won't change. Okay. So that means 4 ones or triple one or double one or even single one is nothing but if you are considering this whole number in the 2's complement form, equivalent decimal is minus 1. Fine. Now plus 5 you are adding with minus 4, plus 5 you are adding with minus 4. That means here resultant answer what you are getting, plus 1, plus 1. Now just observe. Here if you are getting leftmost side 1, if you consider that one also in the final answer, because of this sign bit 1, your answer seems to be negative. But actually plus 5 when you are adding with minus 4, you are getting positive number. When you are getting positive number, sign bit should be 0. Sign bit should be 0. The moment if you ignore this one, then your answer is perfect. Sign bit 0 indicates positive number, remaining bits give the magnitude. Yes, it is match. Okay. Now another 2 cases also just observe. Here in this case, plus 5 plus 4 you are adding, plus 5 plus 4 you are adding. That means here resultant answer will be what? Positive number. But now just observe. If you consider 4 bits, here sign bit 1 indicates negative number, but actually you require positive. That means here I am considering one more bit I am appending. That sign bit here in this case it should be 0 because you are getting positive number. Remaining bits whatever you got, that give the magnitude. Okay. Similarly the last case, here minus 5 plus of minus 4. That means minus 9 you are getting. Minus 5 plus of minus 4, that is nothing but minus 9. Right. So now just observe. I am putting the position weights here. 2 power 0, 2 power 1, 2 square, 2 cube, 2 power 4. Since the sign bit here, if you consider this one as 1, then minus 2 power 4 is nothing but minus 16 plus minus 16 plus here triple 1 is nothing but what? 7. So from there you are getting minus 9. Now just observe. When you are adding two negative numbers, ideally answer should be negative. That time we are considering leftmost side 1. But when you are adding positive number with negative number, even though you are getting leftmost side 1, you have to. I hope you got the clarity. In which case you require extra bit, in which case you don't require extra bit. See, in all the 4 cases we are adding numbers only. But since the context is the given numbers are represented in 2's complement form, if both the numbers are positive, ideally answer should be positive. If both the numbers are negative, ideally answer should be negative. But when you are adding one positive number with negative number, that time actually you are performing subtraction. So whenever you are performing subtraction, you don't require extra bit. So conclusion point is simple. If the sign bits are different, if the sign bits are opposite, that time if you are getting leftmost side 1 after adding those 2 numbers, then please ignore. But when the sign bits are same, like here 1 1, that time if you are getting leftmost side 1, please consider. This is a very, very important concept. So here what is the conclusion? Plus 5 plus 4 when you are adding, you are getting plus 9. For representing plus 9 in 2's complement form, 4 bits are not sufficient, overflow occurs, so that's why we consider one more extra bit. But generally most of the time, whenever you require extra bit, definitely 1. No, need not be. So 1 you are considering if the sign bits are 1. Okay. 0 you are considering if the sign bits are 0. Simple logic. See, simple logic. I am giving one more point because this concept is very important. I am touching one more great insight point here. See, as long as you are adding 2 positive numbers, if you are getting here only positive number, that means sign bit is 0, that time you don't require extra bit. Okay. But when you are adding 2 positive numbers, but here you are getting negative number. Okay. If you are not considering any extra bit, just have observation. Here zeros, here also if 0, that means there is no extra bit. Okay. But here sign bits are 0, but you are getting 1, that means you require extra bit. That bit should be 0. Okay. Because here positive numbers you are adding, so ideally answer should be positive. Similarly, if you are adding 2 negative numbers, If you are getting here only 1, that means you don't require any extra bit. But when you're adding two net numbers like this, if you are getting here 0, that means you're adding two net numbers, but your answer seems to be positive if you're considering this many number of bit. That means here overflow occurs. So to avoid the overflow, you require extra bit. Since sign bits are 1, accordingly you have to type it. That's all. It's a very, very important concept. Yes, I hope it is clear for everyone. Right. Now with this logic, later in your free time, here also you can apply. So you'll be getting whatever the decimal equivalent here, after you are performing addition, you will be getting post number. That is the reason when you are getting post number, ideally sign bit should be 0. But if you consider this 1, your answer seems to be negative. That is the reason whenever sign bits are opposite, but if you are adding two numbers in two count form, leftmost side if you are getting 1, that means extra bit you are getting 1. Ignore. Not at all required. Because you are performing actually subtraction, just like these two cases. In this case also, like -5 we are adding with +4 or +5 we are adding with -4. That means actually we are performing subtraction. Right? When you perform subtraction, you don't require extra bit. But now just observe these two cases. You are adding +5 with +4 or -5 with -4. That means you are adding two post numbers, two net numbers. That means when you're adding, you may require extra bit. But that extra bit should be 0 provided if the sign bits are 0. Extra bit will be 1 provided if the sign bits are 1. In which case you require that one, that logic also I told. Okay, very, very important this one. Yes, next question. I hope all of you can answer this question easily. Yeah, in this question, if you observe, you have to choose the correct option or options. Either one option or more than one option can be correct. So whichever options are correct, you have to choose. The minimum number of bits required to represent 3-digit decimal number. Okay, so when you're having decimal number for a single digit, maximal you can represent is what? 9. Like that, 3 digits are there. That means the maximum value is going to be 999. Maximum value is going to be 999. Fine. This is the decimal number you are having. Now, for this decimal number, 3-digit, the minimum number of bits required to represent the 3-digit decimal number. Regarding that, here 4 choices are there. Among these 4 choices, you have to choose the correct option or options. Okay. Now, with respect to unsigned, 2 choices are there. With respect to BCD, 2 choices are there. Now, 999 is there. Okay. When you're having one decimal number 999, okay. In order to represent that one, we require 10 bits. We require 10 bits in unsigned case. 10 bits we require in unsigned case. Because when you're having 10 bits, the corresponding range you are getting 0 to 1023. That means total number of values are 1024. Yes, 999 we can represent with the help of. In order to represent 999, we require 10 bits. Okay, so that means as of now we are getting option A is correct. Sorry, option B is correct. So option A obviously wrong. Right. Now, among C and D we have to decide. Very simple. With respect to BCD code, for every decimal digit we require 4 bits. That means since we are having 3 digits, 3 into 4, that is 12 bits. 12 bits we require in BCD code, whereas 10 bits are sufficient in unsigned code. Say for example, 9 is nothing but what? 1001. Like that, 9, 1001, 9 is nothing but 1001. Like that, totally you are getting 12 bits. Okay, so for this question, 2 choices are correct, B and D. Yes, very good, Jitsu, very good. For this question, 2 correct choices are there, option B and option D. So far, we have discussed the questions regarding first chapter, that is number systems and codes. Okay, now let us solve the questions regarding second chapter, that is Boolean algebra and K-maps. Okay, right. So whatever the questions here we are discussing, as I mentioned in the beginning also, we are touching all the important concepts and most important concepts, and even variety of questions also, and expected questions for your coming GATE exam. Okay, and not but not the least, wherever in general students may do silly mistake or conceptual traps are there, even those areas also we are covering, so that you people, because you are learning now, at least definitely you can overcome. In general, the students, wherever there is a possibility to do the silly mistake, you people can overcome such kind of errors you can avoid. Okay, you can attempt the question correctly, and not but not the least, how to solve the, how to understand the question and how to solve the question in less time. That is also most important, as the session title is score booster, GATE score booster. So definitely, in order to increase your marks, in order to increase your marks in the GATE exam, and in order to increase your confidence also regarding this particular subject, so definitely you people are getting, by the end of today's session, you are getting one great feel that due to any reason if you miss today's session, even whoever not able to attend live session, no problem, but you people can watch later in the recorded, because the session will be available in our YouTube channel as it is. Okay, so definitely you people can cross check. Due to any reason if you miss this session, and after watching this session, what was the impact, what was the difference, you can cross verify. If you come to know that you felt like I have missed a great, then definitely if you feel like that, then better try to attend tomorrow's live session in the as the timings, whatever 5 to 8 is there, try to attend the live session. Okay, of course, in terms of learning experience point of view, there is no difference and all. Due to any reason if you miss live session, no problem, you can watch tomorrow's session also in the recorded. But whatever the queries you are having or doubts you might be having, if you want to get it clarified, try to attend the live session. Okay, right. So this is the question, you are having the Boolean expression, you have to do the simplification. Okay, you have to do the simplification. See, regular approach is what, here two terms are there, here two terms are there, just like normal maths you can do that simplification and all. It will take more time. Of course, you will get correct answer, there is no doubt in it. But if you want to solve some questions of Boolean algebra in less time, if you know distributive law, LHS to RHS, you know the same distributive law, RHS to LHS, wherever there is a possibility, if you can apply, you can solve the question in less time. Okay, what is that one? Okay, just for reference, I am writing here. Suppose example, x plus yz is there. X plus yz, by using distributive law, we can write like this. X plus y into x plus z. This is a distributive law, LHS to RHS. This one, I hope everyone familiar. Whoever not familiar, you can give simple proof only. Consider this term, do the simplification, you will be getting this one. That's all. Okay. Now, when you know distributive LHS to RHS, when you are saying A equal to B, that means B equal to A. So that means wherever required, you can write, matlab, if you are having RHS term, in one step you can write LHS. Okay. So I am just rearranging this equation. X plus y into x plus z is equal to. Right. Very simple. How to write in one step? Just have observation. In these two brackets, what part is common? X plus, copy that one as it is. Now, whatever the leftover terms are there, so among the leftover terms are variables, you have to perform logical AND. That means y. Yes, you are getting this. So this law, distributive law, RHS to LHS, we are going to apply in this particular question. Okay, like this, wherever required, you can apply so that you can save the time. Okay, but if you don't know, then you can follow regular approach. Definitely you are getting same answer. But if you want to maximize your score, that means you have to solve the question less time. Wherever possibility is there, just try to apply this one. Definitely you can save the time. Okay, now here first of all, whatever the given equation is there, so just write down that one. A plus C, I'm copying as it is. Yeah, A plus C as it is. Then from the middle term, we can take A as common. A you can take common, then what you are getting? B bar plus C. A if you take common, then B bar plus C. Right. Then from here, From here, what you are getting? A bar, C bar plus B bar. Okay. So I'm just applying commutative law with respect to R operator. So that means you can write B bar plus A bar C bar. Yes. I have applied commutative law with respect to R operator. So that means you can interchange the order of terms. B bar here, A bar, C bar. Now just have observation. Whatever I told just now, x plus y into x plus z, you can write in one step, x plus z. Okay. By using that logic, in these two terms, B bar plus is common. So copy that one as it is. Now here among the leftover terms, you have to perform logic line. C into C bar is what? 0. That's all. C into C bar is 0. Next, here also you can apply similar logic. Like A I am copying as it is. Okay. A is there. So A I am writing it as A plus 0. Then A plus C. Now here also you can apply same logic. A plus you can copy as it is. Then 0 into C is what? 0. 0 into C is 0. Then you are getting here B bar. So from here final answer you are getting A into B bar. That is there in option A. See here, if you want without writing like this also you can do, like A into A is A plus A into C is AC. So you can take A as common. 1 plus C is nothing but 1. So finally you are getting A only. Okay. But because I discussed this law, distribute law, RHS to LHS, so here also you can apply. That is the reason I have rearranged it like this. A I have written as A plus 0. Yes, I hope it is clear. Okay. Now, next question. You are having one Boolean expression like this. You have to get the simplified expression. So among the 4 choices, which one is going to be correct, that you can choose. I'm giving 1 minute time. All of you can give it a try. Yeah, this is very, very important law, one of the most important law and powerful law of the Boolean algebra. In general, many of the students may feel that whatever the given expression like this you are having, that itself is the final minimized expression. But with the help of one law of the Boolean algebra, if there is a possibility, if the 2 conditions of that law are satisfied, then definitely can bring 3 terms into 2 terms. But if the 2 conditions not satisfied, then definitely that 3 terms whatever you are having might be the final answer. Okay, right. Now here just have observation in this particular question, like the middle term, if you observe, Q R is there. That means here in this case Q is present here, R is present here. In this particular term, what is the missing variable? When you observe whole expression, it is a function of 3 variables, right? Among the 3 variables, which variable is missing in the middle term? Yes, Q R present, that means P is missing. So what is the first condition? Very simple, like whatever the term you have considered, like among those 3 terms, this term can present anywhere. It can present in first or second or third, but trial and error, but by observing, you will be getting to know. What is the first condition? whatever the term in which whatever the variables present, those variables should be distributed in other two terms. Like Q is present here in this example, R is present here. Even it can be ulta. That means Q can present here, R can present here. That is the first condition. So it has satisfied. Now second condition, in that particular term, what is the missing variable? That missing variable should present in one of the term as normal and in another term in its complement form. In this example, normal form P is here, complement form P bar is here. Even it can be ulta. That means P can present here, P bar can present here. So these are the two conditions. If these two conditions satisfied, then this particular term is the redundant term by using consensus law. I hope all of you know regarding consensus law. Now, this is the two conditions. These are the two conditions, whatever I discussed. Now, final answer what you are getting, P bar Q plus PR, P bar Q plus PR, that is there in option B. Okay, by using consensus law. Okay, by using consensus law, we can bring three terms into two terms, provided if the two conditions are satisfied. Yeah, this is very, very important law. See, already we discussed one of the important law, that is distribute law. Okay, distribute law LHS to RHS or RHS to LHS, based on the requirement you can apply. And after that, one more important law, consensus law. Okay, right. Yeah, next question, this is MSQ. Here you are having one Boolean function. For that, you have to apply dual, and regarding that, four choices are there. Whichever options are equivalent, you can choose accordingly. So dual means very simple. You have to interchange logical and logical OR operators. You have to interchange. If zeros and ones are there, you have to interchange. You have to replace. Okay. So here, whatever the given expression is there, for that you apply dual. So A bar B is there. Dual is what? A bar plus B. A bar B you are getting, dual is A bar plus B. A bar plus B. Okay. Here logical OR is there, logical AND. Then AC is there, dual is A plus C. A plus C. A bar plus P into A plus C, that is there in option B. Yes, very good, Jitsu. Very good. Option B. But this question is what? MSQ. MSQ. You have to verify remaining choice also. Okay. A bar plus B into A plus C. Here A plus B bar into A bar plus C. So obviously A won't be correct. Okay. Among A and B, B is going to be correct. Now, if you do further simplification, A bar into A is what? 0. Then you are getting what? A bar C. A bar C. Then B into A we can add as AB. Then B into C. B into C. Now you are getting three terms. Okay, A bar C plus AB plus BC. So here in C and D only two terms are there. Okay, now just cross verify. Whenever three terms you are getting like this, if you feel that itself is the final minimized, then before you are concluding that is the minimized, you can use Brahmastra of Boolean algebra, that is consensus law. If the two conditions of consensus law are applicable for that equation, then damn sure you can bring three terms into two terms. But if the two conditions are not satisfied, then definitely that might be the simplified equation for that question. Okay, now here also just observe, here B is present in this particular term. Okay, B is present in this particular term. Then C is present in this particular term. Now in this particular term, what is the missing variable? Missing variable is A. So that is present here normal, and in its complement form is present here. In this case, this is the redundant term. So A bar C plus AB. Yes, that is there in option D. So obviously this won't be correct. A bar C is correct only, but here BC you are getting. But actually you are getting AB. BC is the redundant term. So for this question, two correct choices are there, option B and option D. Yes, very good, Jitsu. Very good. So in this way, In this way, for MSQ questions, there will be suspense and surprise among the given 4 choices which are really correct. Okay, that's why I'm covering with the help of variety of questions. I am covering type of with respect to gate exam point of view, whatever the type of questions are there that we are covering, and even with the help of these questions, whatever the great insights are there, conceptual understanding is there, whatever logic you have to apply, each and everything I am covering. So that in this manner, what is happening, whoever thoroughly prepared by this time, you might have learned, you might have gained the knowledge and all, that's okay. But whatever the knowledge you have gained, how to apply that knowledge in order to solve the questions in the GATE exam. That techniques, tips, everything you are getting with the help of our sessions today and tomorrow regarding digital circuit subject. Okay. Right. Now, the next question. You are having one Boolean function A XOR B XOR C XOR D. It can be represented as, you are having 4 choices. 2 choices are there in sigma m form, 2 choices are there in pi capital M. So, once again, question is of MSQ type. All of you can give it. Yes, what is the first observation? See, when you're having 4 bits or 4 variables, 4 bits or 4 variables, in general, you'll be getting 16 combinations. In general, you'll be getting 16 combinations like 0 to 15. 0 to 15. Okay. In terms of decimal equivalent, but in terms of binary means 4 zeros to 4 ones. Okay. Now, here among all the 4 variables, XOR operation is there. That means whatever 16 combination you are getting, among which half of the combination will produce 1, remaining combination will produce 0. Okay. See, regarding XOR function, one of the important note point is XOR function, output will be 1, output of XOR equal to 1, output of XOR will be equal to 1, if odd number of ones are present in the input. If odd number of ones are present at the input. So whatever the binary combination you are considering, in such a manner, in that binary combination, if you are getting odd number of ones, then output you are going to get 1. Now, for whichever input combination you are getting 1 as the output, respective input combination is nothing but, respective input combination term is nothing but min term, right? Now, with the help of that understanding, now just observe min term 1 is there. 1 means 0001, yes, it is satisfying. Number of ones you are getting 1. Like that, just observe. In 2, 0010, single 1, 4, 0100, 7, 0111, 8, 1000, 11, 1011, 13, 1011, right, 14, 1110. So, whatever the numbers, min term numbers are there, convert into binary. In that binary combination, in every combination, you are getting odd number of ones. So, that means here, option A is correct. The moment here in this particular range 0 to 15, when you are saying for these input combination output is 1, in that range, other than this input combination, remaining terms you are going to get output will be 0. That means other than these numbers you are having here in this set, so that is the equivalent pi capital. That is the equivalent pi capital. The moment here A and B are satisfied, so obviously in this question C and D won't be correct. I hope it is clear for everyone. Now, with this understanding, all of you give a try for this question. It won't take much time because Just now we discussed the concept regarding XOR operation among the 4 variables. Now this question is of MCQ only one correct choice is there, but among the 4 variables XOR operation. See, just observe. Here exactly opposite. XOR and XNOR are complement each other. Right. For XOR case, what we told, output you are getting 1. Output you are getting 1 if odd number of ones are present in the input. If odd number of ones are present in the input, that time you are getting 1. Right. That means XNOR case, output you are getting 1 if even number of ones are present in the input. Output of XNOR gate or XNOR function will be equal to 1 if even number of ones are present in the input. If even number of ones are present at the input. Right. Even number of ones. See, earlier and here we are talking with respect to number of ones only. XOR case, odd number of ones, if at the input side if it is present, output is 1. That means with respect to XOR, even number of ones. Okay, right. So earlier for these input combination you got output 1. That means other than this combination, now remaining combinations, XOR gate will produce 1. Okay, so that means these combinations here. Yes, this combination. That means option D. Option D. Yeah, I hope it is clear. Right. Now the next question, just observe here. You are having timing diagrams. Okay, x1, x2, x3 are the inputs. Okay, those are the input waveforms, and function is f of x1, x2, x3. So for this particular function, you are having 4 choices. Okay, among these 4 choices, whichever are equivalent, you have to choose. Okay, and just like earlier question, this question MSQ. Whenever MSQ question is there, I clearly mentioned with highlight color. So easily you should not stop the moment you are getting one correct choice. You have to verify remaining other choice also. So with the help of today's session, tomorrow's session, you are getting good command and practice regarding MSQ questions. Of course, in addition to MCQ and NIT as well. Right. So here, first of all, observation point. See, among A and B, we may not be very much sure. Suppose if you feel like that, then among C and D, just by observation. See, for this question, you can get the clue from A and B, or you can get clue from C and D. Okay. In any manner, accordingly, you can do the visualization for this particular time diagram. Say, for example, since you are having 3 variables x1, x2, x3, okay, among those three variables, you have to perform XOR or you have to perform XNOR. Okay, that is one possible case here among A and B. Okay, now regarding C and D, if you observe, you are having min terms sum together, sigma m form, and just now only we have discussed the questions sigma m, right? Sigma m, and of course pi capital m also we have covered, right? So with the help of this understanding, just have observation with respect to whichever input combinations. Here final output you are getting 1, just focus corresponding input combination. Here 0, here 0, here also 0. That time you are getting what? Output as 1. So x1 bar, x2 bar, x3 bar. Yes, this term is matching. Right? Okay. Then just observe here, output you are getting 1 for what input combination? 0, 1, 0, 1, 0, 1, 1. Right? Yes, 0, 1. Next. Here you are getting 1. Input combination is what? 1, 0, 1. 1, 0, 1. Next. Here you are getting 1. Input combination is 1, 1, 0. 110. Yes. So that means option C is correct. After that, just have a close observation option D. First term is same, second term is same, third term, here it is not same. X1, X2 bar X3, X1, X2, X3. Okay. Here last term is matching. Because this term is not matching, obviously option D won't be correct. Okay. So very simple. By observing C and D, since min terms are summed together, that means here with respect to output waveform, you have to focus because of which input combination you are getting. Okay. Here 1, 2, 3, 4. That means 4 terms you are getting. Yes, 4 terms. Like that, 2 choices are there. And accordingly, you are observing respect to input combinations and you have verified. And because the question is MSQ, now you have to observe A and B also. Okay, among A and B, which one is going to be correct? Any guess? Whatever we discussed, XOR operation, XNOR operation with the help of previous 2 questions. And here for this question, we got to know one of the correct option is option C. With the help of this much understanding, give a try among A and B, whether any one choice is going to be correct or not. Right. Just observe. Here number of ones you are having 0. Here number of ones you are having 2. Here number of ones you are having 2. Here number of ones you are having 2. Here number of ones is 0. Okay. Number of ones 0, number of ones 2. 0 and 2 are what? Even number. That means here XOR function is also correct. The moment XNOR function is correct, obviously XOR function won't be correct. Because XOR function you are getting 1 if you are having odd number of ones present at the input. That time if you get output 1, then only option A. But here number of ones present at the input is either 0 or 2. 0 and 2 are the even numbers. That means you are getting XNOR function. Okay, I hope it is clear for everyone. Now the next question. Yes, once again MSQ. So here in this question you are having Boolean function AB plus CD plus A into C bar D bar. So regarding this particular function, you are having 4 choices. Among these 4 choices, which are going to be correct, you have to verify. So I am giving time for everyone. Just give a try. Yeah. So here if you observe, 2 choices you are having, like number of minterms and number of max terms, right? Another 2 choices you are having, like with respect to number of ones, how many combinations. Okay. for which you are getting output 1 or output 0, like that, right? Okay. Now once again, if you observe, this question is also regarding minterms and maxterms, like how many minterms are there, how many maxterms are there, or for how many combination of zeros and ones you are getting output 1, or for how many combination of zeros and ones you are getting output as 0. Okay, among these 4 choices, whichever choice are correct, you have to choose accordingly, right? Okay. Now just observe here, the given function is in SOP form. Okay, so from SOP you have to get into sigma m. Then with the help of that, the moment you got sigma m, it is self-understandable that equivalent pi cap, right? Okay, so here you can solve this question in any method. Okay, for the time being, I will be discussing one of the shortcut method, like first write the variables order. Whenever you have to decide minterms or maxterms, the order of variables is important, so you can consider accordingly. ABCD. Fine. Now consider term by term. Here the first term is what? AB. That means here A value is 1, B value 1. Regarding CD, you are getting 4 combinations. So just write those 4 combinations: 0, 0, 0, 1, 1, 0, 1, 1. Here for understanding purpose I am writing, but in the exam you can save the time. Just by counting the numbers in the mind and write the corresponding equivalent minterm numbers. Like here you are getting 12, 13, 14, 15. (12, 13, 14, 15). Right? Okay. Next, consider another term, CD. Another term, CD. That means C value is 1, D value also 1. So regarding AB, 2 bits. Once again, 4 combination you are getting: 0, 0, 0, 1, 1, 0, 1, 1. Now here 1, 1 as it is. Now write the minterm numbers: M3, then M7, then M11, then M15. Okay. Similarly, you can try for last term. Last term is what? A C bar D bar. A C bar D bar. Right. Once again, I am writing variables order as it is. So when you consider A C bar D bar, that means here A value is 1, C value is 0, D value 0. Regarding B, 2 possible combination 0, 1. 2 possible combinations 0 and 1, right? So that means here 1,000 is nothing but M8, and 1100 is nothing but M12. Now overall we are having 3 terms. We consider term by term and we have written the respective minterms. Okay. Now the question is, overall for this particular function, how many minterms you are having? Okay. Very simple. What are the minterms here you got? After that you have to sum together. So in that process, like M8 plus M8, suppose if you are getting M8 plus M8 is just like X plus X is what? X. So you can write, you can count. If any minterm appeared more than once, you can consider one time only, counting wise. Number of unique minterms you have to count. Okay. So here just by observation, here M8 is there. M8 here it not, okay, one time only came, fine. Now M12 is there. M12 already came here. So that means one time only you can count, right? Then M15 is there. Here it came like once again, so you can count for one time. Okay. Now here after that, just compare any other minterm is repeated. If it repeated, you can count one time. So 12, 13, 14, 15, then 3, 7, 11, 15, 15 appeared 2 times, then 8, 12. 12 came 2 times. Okay. Now here 4 minterms, then 3. 4 plus 3, 7, 7 plus 1, 8. But sometimes students will count here 4, then 2. 4 plus 2, 10 minterms you are getting. But among those 10 minterms, 2 are like repeated minterms. That means you can count one time. Okay. So that means as of now we are getting number of minterms are 8. Number of minterms 8. That means here option A is correct. Number of minterms are 8. That means option A is correct. The moment number of minterms are 8, for this particular question, number of maximums will be how much? Any guess? Here 4 variable function, 16 combinations are there. Among the 16 combinations, 8 combinations are producing 1. That means remaining 8 combinations are producing 0. So number of max terms will be 8. Okay, for this particular question, number of max terms are 8. So that means here option B won't be correct. Option B won't be correct. Okay, now it is simple. So 8 minterms are there. That means 8 combination of inputs. For 8 combination of inputs, you are getting output 1. Right? Number of combination of zeros and ones for which f of ABCD will be equal to 1 is 4. This is wrong. Here answer should be 8 actually. Okay. Now just observe here. Number of combination of zeros and ones for which function ABCD will be equal to 0 is 8. Yes, that is true. So in this question, option A, option D are correct. It's a very, very interesting question. I hope all of you got the clarity. Is it clear, Jitsu? Any doubt for this question? Currently, whatever the questions we are discussing based on Boolean algebra, and the concept is regarding sigma m, that means sum of minterms. Similarly, another function is product of maxterms pi capital M, and simplified function is SOP, sum of products, and similarly, one more simplified form is product of sum, POS. Okay, currently we are discussing variety of questions based on same concept, sigma m, pi capital M. Right. Now, with this understanding, I am giving time for everyone. This is a very, very interesting question. All of you can give a try. Okay, all of you can give a try. Yeah, I am giving 5 minutes time. Just if you want, you can take break also, no problem. Yeah, I am keeping 7 minutes time, no problem. Yeah, if you want, you can take some break and then you can give a try. Otherwise, if you want to try, you can try. Okay, but this is a very interesting question. That's why I'm giving little more time. Okay, you can give a try. Yeah, Jitsu, your answer is not correct. Okay, you can cross check once again. So here in this question, you are having one Boolean function. You are having one Boolean function. For that, you have to find out the complement. Complement. Okay. See, whenever you are supposed to find the complement, definitely many of the students will apply De Morgan's law. But before you are applying De Morgan's law, if there is a possibility to do the simplification of the given function, first do it. Then after that, if required, you can use De Morgan's law. Say for example, for this question, whatever the equation you are having, whether we can do further simplification or not. AC, B bar, C bar, AB bar. Yes, here with the help of consensus law, there is a possibility. You just observe, A is present here, A is present here, and B bar is present here. B bar is present here. Okay, so in the last term, whatever the two variables are there, those two variables got distributed in these two terms, right? Okay, now in this particular term, what is the missing variable? Missing variable is C, that is present here, normal, and its complement form is present here. Both the conditions are satisfied. Now this is the redundant term. Yes, this is the equivalent minimized function for the given function. Now you can apply De Morgan's law in order to get the complement of this function. Okay, so here you are getting like AC plus B bar C bar we got as of now. For this function, you have to find out the complement. Is it clear, Jitsu, up to this point? See, first step what I have done, the given function simplification possible, I got the simplified function. After that, now you can apply complement. Okay, in order to get complement, you have to use De Morgan's law. Here, first term complement. Yeah, here first term complement, and then logical and second term complement. Right? Yeah. Now here once again you can apply De Morgan's law. AC bar is nothing but A bar plus C bar. A bar plus C bar. Then what you are getting here? B plus C. B plus C. Now just observe. A bar plus C bar you should get, but here A plus C. B plus C you should get, but B bar plus C bar. That is the reason option A is not correct for this question. Okay, right. Now here, the moment you understood that option A is not correct, among B, C, D choices, you are having simplified function, right? Product term sum together, SOP form. So for that you can continue further. Okay. Further you can do simplification. Like A bar into B, then A bar C, A bar B, then A bar C, then B into C bar, then C bar into C is what? 0. Okay, I am just ignoring. Because when you are adding 0 to any function, resultant answer will remain same. Okay, now once again you are getting 3 terms, but here if you observe, in these 3 choices, 2 terms. Okay, whenever 3 terms you are getting, but the final answers, if you are having final choices by observing 2 terms are there, that means with the help of consensus law, you can get into 2 terms. Okay, once again just have observation, like here B, and then yeah, so B is present here, then A bar is present here. Now in this particular term, what is the missing variable? C, that is present here, normal form, and its complement form present here. Both the conditions satisfied. Now this is the redundant term. That means here you are getting A bar C plus B C bar. A bar C plus B C bar. Now just observe the choices. A bar C plus B C bar. That means option D is the correct one. Option D is the correct answer. So with the help of today's session, damn sure many of the students are become perfect regarding consensus law. And of course, whatever other concepts and other important laws that we are discussing, and whatever the variety of questions we are covering, whichever question or whichever concept you are little bit feeling like tricky or somewhat difficult, at least with the help of this session, today's session, you are getting becoming stronger in those areas. Okay, similarly even tomorrow's session as well regarding digital circuit subject. Yeah. Next question. This is the question regarding K-maps and the question type is of MSQ. Jitsu, I hope it is clear. For the previous question, final answer is going to be option D, right? Yeah. So far we have discussed the questions regarding Boolean algebra concept, and now we are discussing the questions of K-map, and then we will be discussing questions regarding the last chapter as well. Of course, we already covered first chapter questions in the beginning. Yeah, this is the K-map given, and you have to find out equivalent Boolean function corresponding for this particular K-map. Okay, so just have your observation. First of all, while you are doing the grouping, yeah. So here grouping of, because it is a 3 variable K-map, so first and foremost you will be checking grouping of 2 power 3 adjacently placed ones. That is not possible. Then go for 2 square. That means 4 adjacently placed ones. Yes, here it is possible. And after that, grouping of 4 adjacently placed ones not possible. Then you can do grouping of 2 adjacently placed ones. This one possible, this one more possible, like that. Like that, you have to start from highest power of 2 to the least power. Now you can write the corresponding terms. For this particular row-wise grouping of 4 ones, 4 adjacent placed ones, A value is 0, that means A bar. A value is 0, that means A bar. Okay. Now, for this particular grouping of 2 adjacent placed ones, column-wise B value, C value are 0, that means B bar, C bar. Similarly, for this column grouping, B value, C value is 1, normal, BC. Okay, so here what you are getting, see, 3 groupings you are having. All the 3 groupings are must and should for this particular question. All the 3 groupings are must and should. Yes, you got one correct choice, but for the this question is of MSQ, one more correct choice also is there. Okay, you can cross check. As of now, whatever the option you mentioned, that is true. Yeah. So now all the 3 groupings are compulsory. That means whatever the product terms you got, you can sum together. Okay. So here we are getting A bar plus B bar C bar plus BC. A bar plus B bar C bar plus BC. Now B bar C bar plus BC is nothing but what? BX nor C. Right. Then A bar as it is. So just observe A bar plus BX nor C. Yeah, that is there in option B. As of now, option B is correct. Option B is the correct answer for this question. Yes, as of now, option B. Definitely option A we can eliminate, because here XOR function was there. Right. Now, since the question is of MSQ, you have to verify among remaining options also. Okay, whether any correct option is there or not. Here in this case, A plus BX nor C. BX nor C same, but here A bar. So, but here A is given, so C is also not correct. So, among A, B, C, obviously B is correct. Now, D you have to observe. See, A bar is matching. Yes, correct. Now, here if you do simplification, B bar into B is 0, B bar into C bar. Yes, you are getting first term, B bar into C bar. Next, C into B, we can write it as BC. Yes, we are getting second term. Okay. Like here, B bar, C bar. That means this term, then BC, this term you are getting. Yes. Yes, very good. For this question, 2 correct choices are there, option B and option D. Okay. So for MSQ question in the GATE exam, if you want to get marks assigned for that question, whichever correct options are there, you have to mark. Then only you will be getting marks assigned for that question. There is no partial marking. That is a drawback. But what is the advantage? Suppose here in this question, B, D are correct, but suppose you have chosen A and B. B is correct, that's fine, but A is not correct. Because of that, there is no negative marking. That is the advantage. But drawback is among B and D, you have marked only B, but you haven't marked D. That means because of that, you won't get partial marking. So while you are solving any question, especially MSQ I'm talking, if you want to get marks assigned for that question, you have to verify each and every option, whether it is, you have to figure out among the given choices which are really correct, you have to mark accordingly. Then only you'll be getting marks assigned. Okay. But anyway, here since you're practicing and learning, no issue at all. At least you are getting all the important areas and points wherever you have to focus with respect to your GATE exam regarding this particular subject, digital circuit. Okay. Right. With this understanding, all of you give it a try. Next question. This is also K-map based question. Earlier question is 3 variable K-map. Right. Now the question is of 4 variable K-map, and of course with the help of ones and don't cares, you have to get the simplified expression. So here just by observing, see, whenever you're having choices in the question, first of all, read the given question, what you are supposed to find out, etc., or what they have given, and after that just have an observation of choices. From there also you're getting clue. Okay. Here in every choice you're having 2 terms. That means in this particular K-map, okay, here in every choice 2 product terms are there. That means you have to do grouping with respect to ones. And because here don't cares are there, if any don't care term is helping in order to get the minimized function, accordingly you can do grouping. Okay. And here, because every choice you're having 2 terms, that means 2 compulsory groupings are there, that if you can observe, then accordingly from there you are getting the final answer. Like here, if you observe, like corner 4 1, corner here 1, here 1, here 1. Okay, if you consider this don't care also 1, then accordingly you can do combined grouping of 4 ones. Accordingly, you can do 4 adjacently placed ones here. Right? Okay. After that, here 2 ones are there and 2 don't cares are there. If you consider these 2 don't cares as 1, then you are getting grouping of 4 adjacently placed ones like this. Okay. And suppose if you are continuing further, then another possible grouping also you may get, like first column, last column adjacent. So combined grouping of 4 adjacent placed 1 if you are treating these 2 don't care as 1. But that is the redundant, it won't come in the final answer. Okay, right. So that's why I have done what are the 2 compulsory groupings are there just by observing the choices. Okay, fine. Now for this particular corner 4 ones grouping, the term that you are getting is, right, row wise when you observe Q value 0, that means complement version, and column wise S value 0, once again complement. So Q bar S bar you are getting, Q bar S bar, it is present in 2 choices. So as of now we can eliminate 2 other choices. Yes, very good Jitsu, very good. Yeah, both of you are getting correct answer, very good. Yeah, now you can do grouping of this grouping. For this grouping, row wise, P value 0, Q value 1, that means P bar Q. Yes, P bar Q is present here. That means here option B is correct. So obviously option A won't be correct. Okay, for this question, option B is the correct answer. Right. Yeah, in this way, whenever you are doing grouping with respect to K-maps, okay, whenever the question is regarding simplification, right, if you are having choices, just have observation and then accordingly you can do respect to groupings. And if the question is prime implicant, essential, etc., then you have to do all the possible groupings of adjacently placed ones in decreasing powers of 2. After that, you can decide whichever groupings are compulsory, those are essential. And with respect to minimized function, if any other prime implicants are there, but if it is not used in the final minimized function, then those will be redundant. Okay, fine. And just like here, as I told, suppose if you do this grouping, then you are getting one product term, but if you are adding that one here, that is the redundant term. Okay, that term can be eliminated by using consensus law based on the previous topic. Okay, and with the help of K-map, that law is internally taken care of. Okay, right. Yeah, so far we have discussed regarding two chapters questions, chapter 1 and chapter 2. Okay, number system and codes, and then Boolean algebra and K-maps. Now we are discussing the third chapter questions in this particular session. Okay, right. Yeah, regarding logic gates, we are going to discuss all the variety of questions and most important concepts and expected models for your coming lecture. And in tomorrow's session, we'll be discussing regarding remaining 4 chapter questions of digital circuit subject. Yeah, this is the MSQ question. You have to find out among the like what are the logic gate symbols here you are having. You have to identify the universal gates. You have to identify the universal gates. Question is of MSQ type. Yes, very good, Jitsu. Very good. Here in this question, all the 4 choices are correct. See, generally, many of you by this time aware that regarding option A, option B, right? See, in option A, what you're having? Okay, many of you aware option C, option D. Okay, here say for example, if I consider x and y are the inputs, suppose example, then accordingly what you are getting x y whole bar. That means this is a NAND gate. Okay, similarly here x y are the inputs, then you are getting what? X plus y whole bar. This is a NOR gate. So as of now, you know that NAND gate, NOR gate are universal gates. Okay, accordingly, most of the students will mark C and D only. But here closely if you observe, here you are having OR gate, but input side you are having bubbles. Whenever in bubbles are there, if you are not comfortable, just replace that bubble as NOT gate. Okay, say for example, this circuit you can replace or represent like this, like yeah, inputs you are passing through NOT gates. Okay, so here in this case x y are the inputs, you are getting what? X bar, y bar. You are getting here x bar and then y bar. Okay, and output what you are getting? X bar plus y bar, because it is the OR gate. Okay, now x bar plus y bar, where you are getting? Here only. By observing, not same, but if you use De Morgan's law, this one you can write as x y whole bar. That means NAND gate and bubbled OR gate both are one the same. NAND gate and bubbled OR gate both are one the same. Okay, so that means option A is also correct. Now with this understanding, here direct step I am writing. So x bar, y bar you are getting by using De Morgan's law. You can write it as x plus y whole bar. Yes, so this is matching. That means NOR gate and bubbled AND gate both are one and the same. So option B is going to be correct. So here all the 4 choices, that means you are having 2 choices regarding NAND gate, 2 choices regarding NOR gate, broadly speaking, and we know that NAND gate and NOR gate are universal gates. Okay, right. Now the next question, very interesting one. You are having one circuit diagram. So in this particular circuit diagram, you are having various logic gates, among which logic gate is going to be the redundant. See, earlier we discussed redundant term. Okay, now that particular term is produced by whichever logic gate. Here very simple, among the given logic gates, and just by observation, 4 gates are there in the choices, gate number 1, 2, 3, 4. Among these 4 gates, which gate, even in the absence of it, still you are getting functionality wise same, but unnecessarily if you are considering the given circuit, that is present unnecessarily in the given circuit, that's why we are calling that gate as redundant. So which gate, that one that you have to find out. Yeah, here just observe, A is the input, NOT gate, output you are getting here A bar, then BD are the input. So accordingly you are getting what? A bar BD, A bar BD. Fine. Then here C is the input, accordingly you are getting C bar, C bar. Okay. Then other inputs are B and D. That means you are getting here B C bar D, B C bar D, B C bar D. See, just observe B C bar then D. Okay. Next here AND gate is having two inputs. One input is C, another input is A bar. That means you are getting A bar C. Just have a close observation. A bar then C. Okay. Now these three terms we are passing through OR gate. Now you can write the final expression. Y equal to, just you have to perform logical OR among these three. Okay. So what you are getting, A bar BD plus B C bar D, then A bar C. Now all of you give it a try. This is very, very interesting. Now you have to find out among these four gates which gate is the redundant. As of now, with the help of Boolean algebra concept and with the help of logic gates, accordingly we got the expression. Now try your level best. Try your level best. This function, if there is a possibility to do further simplification, do it based on Boolean algebra concept. Then after that you can decide among these four gates which one is going to be redundant. Yeah, just cross check here. See, directly if you observe, you are having three terms, right? So just try to observe which terms you can take common if there is a possibility. But like that combination, if it's not possible, then three terms are there. If you want to bring to two terms, then you have to apply, you have to verify consensus law. Okay. Now with that understanding regarding consensus law, so here just observe A bar is present in this particular term. A bar is present in that particular term, right? Then BD is present in this particular term. BD is present in this particular term, right? Okay. So that means here you are having one particular term A bar BD, right? A bar is present in the last term and whereas BD is present in the middle term. That means here the missing variable is what? C. The missing variable is C, that is present here normal and in its complement form is present here. Yes, both the conditions of consensus law satisfied. Now you can bring three terms into two terms. That means in the final answer, this term is required. That means the first term is not required, right? The first term, the first time you are able to get because of gate number 1. Even if you remove gate number 1, functionality wise, you are getting same functionality. That's why here gate number 1 is going to be the redundant. So option A is the correct answer for this question. Option A is the correct answer for this question. Yes, very good, Jitsu. Very good. Excellent. Generally, many of the students aware that we can apply consensus law for 3 terms, 3 variables. Yes, that is true. Consensus law always possibility is there for 3 terms only. But you can apply for 4 variable, 5 variable also like that. But whatever the second condition that we are telling, like in whichever term, when you considered with respect to that term, all the variables got distributed in the remaining 2 terms. After that, if only one variable is missing in the term, if that missing variable is present in one of the term normal, other term complement, then we can apply. So that means consensus law we can apply for not only for 3 variable, even for more than 3 variables also. But whatever the 2 conditions we are telling, if the 2 conditions are satisfied, then we can bring 3 terms into 2 terms. Yes, excellent, Jitsu, excellent. Yeah, next question, I'm giving time for everyone. All of you try your level best. Yeah, this is a very, very interesting question. Here you're having one logic circuit, okay, with the help of OR gate, XOR gate, XNOR gate, NAND gate. Okay, you're having one overall circuit is having 4 inputs and 1 output. Okay, now the question is, output Y you should get 1. In order to get output Y1, how many combination of zeros and ones that you are having with respect to overall circuit? When you're having 4 inputs or 4 variable, total number of combination you are having 16. Among those 16 combination, how many combination you are getting 1? That is the question. Here you have to get 1. In order to get final output 1, how many combination of zeros and ones that you can apply here? Okay, right. Now, see, you can solve this question in various methods based on the concept understanding with respect to previous chapter or this chapter, and whatever the logic concepts that you are having accordingly. Now, but if you want to solve this kind of questions in less time, if your basics wise, if you are crystal clear idea, then with the help of that logic, you can easily solve the questions regarding logic gates in a gate exam in less time, especially this variety of questions I'm talking. Now, just observe, in one sense, circuit seems to be like complicated, big circuit, okay, but whenever they're giving in the gate exam, very big circuit or little bit typical, etc., definitely they will keep some inherent logic. If you catch that one, that means basics wise clear, damn sure you can solve in less time. Okay, so the first and foremost observation, no matter what it may be here, overall you are having 4 stages, irrespective of that. Here last stage you are having NAND gate, output you should get 1. Okay, here 2 inputs are there. Now tell me, regarding these 2 inputs, the moment if at least any one input, the moment if at least one input is 0, 0 bar is what? 1. Yes, sir. That means for the timing I'm considering, the moment if you have considered a value 0, the moment you have considered a value 0, irrespective of here what you are getting, whether you are getting 0 or 1, irrespective of that, 0 bar is 1. That is one possible combination. Are you agreeing or not? This is one possible combination I'm talking. See, when you are having A, B, C, D, the moment A value 0, irrespective of B, C, D, you are getting final output as 1. Correct? Now, regarding B, C, D, 3 bits are there, or 3 variables are there. That means 8 combinations you are getting. So here, as of now, you are getting 8 combinations. Number of combinations I'm talking. Okay, fine. Now, another possible case. See, the first case, what I have considered is, I have considered the moment if this is 0, irrespective of this value, 0 bar will be 1. That is the case I have considered. So accordingly, you are getting 8 combination. Okay. Now let us see regarding other possible case. Other possible case means the moment you are getting 0 here, 0 bar is 1. Correct. 0 bar is 1. Now, if you observe closely, okay, earlier case must and should A value 0, must and should A value 0. Now, with respect to A value 0, you are having 8 combination. That means the remaining 8 combination, whatever you are having, definitely A value is going to be what? 1. Definitely A value is going to be 1. That is your observation point. Now, when you considered A value 1, when you considered A value 1 here, 1 plus B is nothing but what? 1. 1 plus anything is 1, logical. Okay. Now, 1 XOR C. 1 XOR C is nothing but what? C bar. C bar. Next, C bar XNOR D. C bar XNOR D. C bar XNOR D is nothing but C XOR. C XOR D. C XOR D. See, whether it is correct or not, you can justify. Okay, just for reference, I am writing. Yeah, for the timing, I am just writing like this. Suppose P exclusion or Q. P exclusion or Q, that is nothing but what? P bar Q bar plus PQ. Regarding 2 input XNOR function, you know. Okay, now in this particular example, P is nothing but C bar and Q is nothing but D. Now accordingly you can substitute. In place of P, you can consider C bar. In place of P, you can consider C bar. Now here C bar, and then you are having extra one more complement, right? And in place of Q, you can put D. In place of Q, you can put D. Now what you are getting? Now what you are getting? C bar whole bar, that is nothing but C. Then D bar plus C bar D, that is nothing but what? C exclusive or D. So this is one of the important note point regarding 2 input case with respect to XOR, with respect to XNOR. Very simple. If both the inputs are complement, then among the normal variables, same operation you will be getting. Suppose if XNOR is there, XNOR. If XOR is there, XOR. But one variable is normal, other variable is complement. Just like this. One variable normal, other variable complement. Among which if you are performing XNOR, among the normal variables, you will be getting opposite function. If XNOR is there, XOR. If XOR is there, XNOR. Okay, in the exam, you can save the time. But here for practice, if you want to verify what are the 2 conditions I told, you can verify in your free time. Okay, now here C XOR D you should get 0. C XOR D you can get 0. C XOR D you can get 0. The possible cases are when C and D are same. Correct? Okay, that means C value, D value are 0. That is one possible case. Right? When you consider that one, here 0 or 1 regarding B. Okay, next another possible case is what? C and D values can be 1. Then also you are getting C XOR D will be 0. You can verify. 0 XOR 0 is what? 0. 1 XOR 1 is 0. So accordingly you are getting here once again regarding B 0 or 1. So here just observe, like here you got 8 combination, here you are getting 2 combinations, here you are getting 2 combinations, right? So 8 plus 2 plus 2, that is 12. Now just before you are deciding whether 12 is the correct or not, just have a close observation whether any combination repeated. Here in this question, not repeated. You can closely observe. Like when you considered A value 0, here you are having 8 combination. Here whatever the cases I am considering, A value is 1. A value 1. Obviously here and here or here and here, there is no intersection part. Okay. That means here 8 combinations, here whatever you are getting, here 0 0, here 1 1. Definitely here there is no intersection. There is no min term is repeating. Here also no min term. First and second or first and third. Okay. Now whatever here you are getting 8 plus 2 plus 2, that means 12 min terms or 12 combinations, whatever you are getting, all those are unique combinations. So For those 12 combinations, you are getting final output as 1. For this question, option B is the correct answer. Option B is the correct answer. Okay, suppose same question, if they can ask in another way, like in this question I asked that for how many combination of ones and zeros you are getting output 1. Same question I can modify as NIT. For how many combination of zeros and ones you are getting output as 0. Then in that case, what is the answer? Total number of combination possible is 16, out of which 12 combination are producing 1. That means remaining 4 combination will produce 0. Okay, that is the NIT question. Similarly, this question they can frame as MSQ as well. Okay, in order to get output 1, okay, regarding 4 choices, they can give in terms of input combinations, right? So what is the 12 combination here you are having? Among these 12 combination, any 4 combination if they are giving in the form of choices, then all the 4 choices are correct. Similarly, in order to get output 0, if they ask regarding input combination of inputs, okay, whatever other than these 12 combination, whatever remaining 4 combination you are getting, if those 4 combination, if they have given as choices, then in that case, all the 4 choices are going to be correct. So in this way, question is 1, circuit is 1, but with the help of one circuit or with the help of one question, you are getting all the 3 possible type of questions regarding gate exam point of view. MCQ is there, MSQ is there, NIT is there. So my conclusion point here, very simple. Whatever you, by this time you already studied, and regarding not only the subject, any subject with respect to your branch, whatever so far you have prepared, like whichever subjects you thoroughly prepared, when you are getting chance for revising or practice for those subjects in future, okay, you focus on whatever the notes that you are having. But in every chapter, just focus selective questions based on your available time and based on your interest. Try to solve in this manner. Just contemplate. I'm not telling that every question, all 3 types of questions possible. No. But at least if you contemplate for 10 questions, maybe 1 or 2 questions, if you can figure out, then that is more than sufficient. Okay. With the help of this, what is happening? You are getting deeper insights, and all the, what I mean to say, with the help of optimum number of questions, all the variety of concepts or all the variety of questions that you are covering in less time. That is the most important when you are getting closer to the gate exam date. Okay, right. Fine. Now with this understanding, now all of you can give a try. Next question. I am giving 1 minute time for everyone. All of you can give a try. Yeah, here you can observe they have given pi capital M. The given function is pi capital M, right? And here, whatever the simplified function you are getting, in order to implement that function, which logic gates, with the help of which logic gates you can implement. Realized using only 2 input gates. So for that, here you are having 4 choices, with the help of which set of logic gates you can implement that function. Okay. See, since pi capital M is there, if you want, you can use K-map, and accordingly you can get simplification. Okay, that is one procedure that you can give a try later. Okay, but for the time being, we can solve this question as I told earlier regarding Boolean algebra concept, distribute law, RHS to LHS. With the help of that logic, you can solve. Wherever that possibility is there, if you can apply, you can save the time. Okay. So here M0, M6, right? M0, M6 you have to multiply. Sigma means sum, pi means product. Okay. So max terms you have to multiply. Here in this case, 0 is nothing but 000. So A plus B plus C, right? Then 6 is nothing but 110. 6 is nothing but 110. So A bar plus B bar plus C, right? Okay. Now here, for the time being, in order to apply distribute law RHS to LHS, I am just rearranging like this: C plus A plus B with respect to commutative law with respect to R operator, C plus A bar plus B bar. Now closely observe regarding distributive law RHS to LHS. Yeah, in both the brackets, common part is what? C plus. Copy that one as it is. Now after that, whatever the leftover terms are there, among which you have to perform logical and, right? So here the terms you are getting A plus B and then A bar plus B bar. A bar plus B bar. Right? Okay. Now C you can copy as it is. Then you can do further simplification. A into A bar is 0. A into B bar plus B into A bar. That means A bar B. Then B into B bar is what? 0. Okay. So A B bar plus A bar B. We can write it as A exclusive or B. Now just observe. For implementing A XOR B, we require one XOR gate, 2 input XOR gate, and then here in order to perform C plus, this expression you can treat like Y, C plus Y. That means in order to perform here, you require OR gate, right? So that means here XOR gate required, OR gate required. That means option B is the correct answer. We require a 2 input XOR gate and then 2 input OR gate. Yes, very good, Jitsu. Very good. See, in general, the procedure for solving this question, many of the students will follow. Since pi capital M is there, they will be using 3 variable K-map and accordingly they will be getting PYs. That's true. Okay. And after that, whatever the PYs you are getting, you can do further simplification. Okay. Right. That is one approach. And here what I have done, I have used distribute law RHS to LHS concept. Okay. Fine. Yeah. Next question. So you are having one Boolean function AB plus CD plus EF. Okay. For implementing this function, how many 2 input NAND gates required? That is the question. How many 2 input NAND gates required? See, this is one of the important concept. Regarding logic gates, in general, you will be having 2 or 3 variety of questions. Okay. One variety, whatever so far we have covered, like they will be giving circuit diagram. They will ask the simplified expression, or in order to get output 1, what is the condition for inputs, etc. Those are the variety of question. And another variety of question is regarding minimum number of NAND gates or NOR gates. Okay. Yeah. Here you are having AB plus CD plus EF. That function is in which form? SOP. SOP. So here you are having the function. The given function is in SOP. Yes. Whenever you are having in SOP, definitely you can easily implement that function by using NAND gates. There is no doubt. Okay. And here, whatever function is there, that itself is a simplified. We cannot do further simplification. Yes, that is true. Now, whenever you are having SOP, very simple, you have to put double complement. Okay. Double complement. Then the function will remain same. Sorry. Yeah, function will remain same. Now, For inner complement, apply De Morgan's law. For inner complement, apply De Morgan's law. Then what you are getting? First term complementing. Each and every term, individual will get complement, and then logical are replaced with logical. AB bar, then CD bar, then EF bar. Okay, and keep external complement as it is. External complement as it is. Okay. Here the context is what? Minimum number of 2 input NAND gates required. Okay, here 2 input NAND gate, 2 input NAND gate, 2 input NAND gate. But for this external complement, if you observe, 3 input NAND gate. But here context is 2 input NAND. Okay, now what we have to do? Like any two terms you can consider. Like it is in the product form only. So double complement once again you can put. So for the timing, I'm putting double complement here. Then external complement as it is. Now you can observe how many NAND gates we require. AB bar 1, CD bar 1, EF bar 1. As of now 3, right? Then AB bar you got output at one NAND gate. CD bar you got output of another NAND gate. Now those two outputs you are passing through one NAND based inverter. Yes. It is like, say for example, X and then Y, XY whole bar. Yes. After that output you are passing through one more NAND based NAND gate, okay, or NAND based inverter, whatever. Then after that, this term you consider like X1, this term is like X2, X1, X2 whole bar. So here 1, 2, 3, 4, 5, 6. We require 6. Okay, we require 6 NAND gates. Option C. See, by looking at this expression, sometimes few students may answer like 4. See, when 4 can be correct, if they don't mention number of inputs, that means you are completely having freedom. Number of inputs for NAND gate, either 2 or more than 2. Any number is completely you are having freedom. Then here if you observe 1, 2, 3, then 4. But when clearly mentioned 2 input NAND gate, so when they clearly mention 2 input NAND gate, you don't have choice that 3 input NAND gate is available. Correct? So that is the reason. So like when you're having product form like this, so you can put once again double complement. So accordingly you require further NAND gates. Okay, that is a twist is there in this question. Okay, final answer for this question is option C. Option C. Option C is the correct answer. Right. Now the last question. Yeah, last question for this chapter and of course for this session as well. Once again, the question based on regarding NAND gates. The minimum number of NAND gates required for implementing the Boolean function. And here one of the important note point, as we discussed earlier, if the function is in SOP, definitely you can easily implement by using NAND gates. Definitely we can implement by using NAND gates. Okay. And here the function, it is looking like product terms sum together, but you have to verify whether really it is a simplified form or whether we can do further simplification. If simplification further possible, first do it. If simplification not possible, then you can proceed whatever the logic here we have discussed. Okay. Yeah, good evening, Pawan. You have joined at the last session, last question when we are discussing in this session. Okay, no problem. Whatever we have discussed so far, you can watch in the recorded form later. Yeah. So whatever the function here you're having, whether we can do whether we can get further simplification or not. Yes, we can do. With the help of which law? Yes, with the help of Brahmastra of Boolean algebra. Correct? Regarding laws of Boolean algebra, that is consensus law. Yeah, with the help of that law, only possibility is there. You can bring 3 terms into 2 terms. Okay. Provided if the respective 2 conditions are satisfied. So here in this case, yeah, B bar is present here, B bar is present here, and then C is present here. So that means with respect to this term, with respect to the last term, B bar C, both the variables are distributed here. That means B bar distributed here, C distributed here. Now, in this particular term, what is the missing variable? A. That is present here normal and its complement form present here. Yes, both the conditions satisfied. Now we can bring 3 terms into 2 terms. Yes, so as of now we are getting f of ABC equal to A bar B bar plus AC. A bar B bar plus AC. Right? Okay, now this function is what? SOP form. This function is SOP form. Yes, you can follow this logic, whatever just now we have discussed. Double complement. Yes. So A bar B bar plus AC double complement. Now, you can apply De Morgan's law for inner complement. Right. Yes. Now just look at this expression and try to mention what is the final answer for this particular question. Yeah, it is very simple. Just have your observation. See, for getting A bar, one NAND based NOT gate required, and similarly B bar, one NAND based NOT gate. Then here 2 input NAND gate, here also 2 input NAND gate. After that, consider x1, x2 whole bar. So we require 5 2 input NAND gates. Okay, answer for this question is 5. See, whenever in the question, if they don't specify the inputs are available in which form, by default available in normal form. Just like when you're saying XOR gate, you'll be giving inputs in which form? Normal form. But in some context of the question, in some question they can clearly mention inputs are available in both normal and complement. That means, say for example, A, B, C available, like that A bar, B bar, C bar also available. That time here you should not count. Just like A is available, C is available, A bar, B bar also available. Okay, in that case, 1, 2, 3, 3 are sufficient. But in any question, if they don't specify the inputs are available in which form, by default normal. So whenever complement version of the variable you are getting, you have to use the NOT gate, or with the help of NAND means NAND based NOT gate. NOR gate means NOR based NOT gate, like that. Okay, in that way we have to generate. Okay, so these are the questions which are expected models for your coming gate exam with respect to the first 3 chapters of digital circuit. Okay, we have covered all the important concepts and most important concept based questions, and through the questions you got the models and concepts, and whatever the great insights are there, learnings are there, each and every point whatever required with respect to your coming gate exam that I have covered in the limited 3 hours time regarding first 3 chapters of digital circuit subject. I hope all of you got great learning experience with the help of this session. Okay, as I mentioned earlier also, whoever watching this session later, even in the form of recorded, okay, you people can cross check before attending the session and after attending the session, whether there is a huge improvement is there in you in terms of your learning regarding this subject, whatever 3 chapters we have discussed. Regarding 3 chapters based questions, whatever we discussed, if you felt like great improvement is there, then try to attend tomorrow's session in live. Okay, timings will be as usual 5 to 8. So try to attend tomorrow's session live based on your time availability. Okay, but due to any reason, if not possible, no issue, you can watch in the recorded later. Okay, so in tomorrow's session, we will be covering remaining 4 chapters, whatever you're having, like combination circuits, sequence circuits, okay, and then data converters, logic family, with respect to EC and IN. With respect to electrical means, the syllabus is up to data converters. With respect to CS branch students' point of view, the syllabus is up to 5th chapter. Okay, right. Yeah. So whoever attended in this particular session, okay, participated actively and got the correct answers for most of the questions, and even whoever watching this session later and got for many of the questions got the correct answer, in advance I am telling, okay, hearty congratulations for all the toppers of digital circuit subject. First of all, whoever attended this live session, and after that whoever watching the session even in the recorded form as well. Okay, right. Yeah, Jitsu, hearty congratulations to you, and of course whoever other students attended, whoever got for most of the questions correctly, hearty congratulations from my side for today's session. Tomorrow also, whoever want to be in the toppers of this particular subject, so try to attend live session so that accordingly I can say your names in the live session, right? You can feel proud. Yeah. So if you're having any queries, whatever 3 chapters related questions we covered, so you can mention. If anything generic query also if you're having, you can mention in the chat. I will be responding in some time. Okay. Yeah. Whoever not yet enrolled at our IMS GATE Academy for any of the programs, but if you are targeting for GATE 26 exam, so try to enroll for our test series program, test series plus program, so that you are getting, see, if you want to get very good rank, if you want to get confidence in your GATE preparation, definitely the first and foremost thing, you should learn the concepts. Of course, whatever the like by this time, whatever the learning process that you have done regarding your GATE preparation, that is one level, and you might have done practice also. But unless otherwise you exposure to the test environment, you never get confidence, or you never get the feel that I can get very good marks in the GATE exam. If you want to get very good marks in the GATE exam, definitely first and foremost you have to get confidence before you are going for the GATE exam. So in order to get that one, the test series plus is going to be a very good platform at our institute, so you can best utilize. Okay, based on your available time. Okay, see all these features you are having, so I will be showing further also. See here you can observe with respect to your branch. Suppose example, if you are from EC, with respect to your previous year questions, okay, 33 years questions you are getting with respect to your core branch EC, and in addition to that regarding maths and GA, you are getting 33 years GATE questions not only from EC, electrical, instrumentation, mechanical, civil, computer science. That means total 6 branch questions of maths and GA that you are getting in addition to your respective core branch technical booklet. Okay, like that. Suppose if you are from computer science, you will be getting technical subject computer science questions, and along with that maths and GA 33 years booklet. Okay, so based on your available time, you can practice at least selective questions. Say for example, just like today's session, if you observe, with the help of questions, see there are 2 ways to learn any concept or subject, etc. Ideally, first and foremost, you have to learn the concepts and make the notes and then solve the questions. That is the regular way when you start preparing for any exam in the beginning. But when exam date is coming closer, there is a second approach through which you can speed up your learning process, and of course confidence and everything, in order to make sure that your preparation is going very well in the limited hours. Okay, so for that, the GATE PYQ booklet is one of the great resources, I can say. You can observe glimpse here. For every chapter, we have provided all the important points, key points, note points, everything we have kept in the beginning of chapter overview, and even in the solutions also for solving some specific questions. Wherever some key points, note points are there, that we have put in the box. Okay, key points we have mentioned, and we have provided detailed solution also. And for some typical questions, we provided even video solution here we provided. Generally, you people are doing QR with the help of QR scanner in the mobile, used to scan the QR code for UPI transaction, right? Now, in our PYQ booklet, you are having QR code that is for play. When you scan that one, our respective video solution will be played. Okay, so in this manner, you can get best experience before you are going for GATE exam. That is a specialty that you are having regarding our PYQ booklet. And similarly, you can observe regarding maths. Okay, and as I mentioned here, 130 plus tests we are having overall. So you can observe regarding chapter wise tests we are having, and then even subject wise test, basic, advanced, and multi. 3 levels of questions papers are there, and then full length mock tests are there. So based on your available time, at least selective chapter test you can attempt, and selective basic subject test you can attempt. And if you are getting enough confidence, then you can attempt advanced subject test. Otherwise, if you don't have that much time, you can keep hold of this and you can go for full length mock test. But before attempting this one, you should feel comfortable for minimum 6 subjects. Then definitely you can go for full length mock test, and accordingly you can check. And here, with the help of test series, see, of course, your ultimate objective is you have to get whatever the marks you are supposed to get. But test after test, what you are getting to know is in which concepts or which models you are very much strong, in which concepts or which models you have to further revise or practice. That you are getting to know. That is happening with the help of our test series program. Okay, so this is one thing, and as I told earlier, GATE PYQ booklet. So with the help of these 2 resources, whatever the available time you're having, you can best utilize. Because in the live sessions, whatever we are discussing, today 3 hours, tomorrow 3 hours, definitely we are covering all the important models. But unless otherwise you practice, unless otherwise you check your performance through the test, you never get that confidence. Okay, right? So in order to make sure that you are reaching to self-confident level in such a manner, you can perform well in the upcoming GATE exam. So definitely, for whoever students not yet enrolled for any of the program at our IMS GATE Academy, I'm strongly recommending, once again I'm telling, you can enroll for test series plus program. You will feel proud before you are going for GATE exam. Okay, right? So these are our toppers regarding GATE 2024 achievers, and similarly GATE 2025 toppers, right? So, and whoever targeting for next year, that means not for GATE 26, GATE 27, okay, or even GATE 26, like say for example, if any of you already given one attempt earlier, now you are passed out, okay, somehow other you are having decently some knowledge, but somehow other you couldn't qualify earlier, or you might have got only minimum marks. But still, if you are having, like if you want to spend good number of hours per day, like 8 to 10 hours per day, still if you want to get best result in the coming GATE 2026 exam, I am strongly recommending you can enroll for SLP program, right? But if you want to, like, even though limited time is there, but sir, I want to attend some of the classes for even live classes, then you can enroll for live online also for GATE 26. But based on your available time and whatever is best suitable, accordingly you can do it. Definitely, whatever the investment currently you are doing before your GATE exam, definitely with the help of whatever time you have invested for your preparation, definitely through that you can get best result. Okay, and whoever targeting for GATE 27, so based on your convenience, whichever program is suitable, accordingly you can enroll. And before going to enroll, if you want to get complete details regarding all these programs in detail, regarding counseling session, link is provided in the description of this particular video. You can book the free counseling session, and our education advisor will discuss each and every program feature, and whatever is best suitable for you, accordingly you can enroll. Okay, so that you can get maximum benefit from our institute. Okay, right. Yeah, not the least, as I mentioned in the beginning of this session, our Telegram link is provided in the description of this particular video. All of you can kindly join if you're not yet joined. Yeah, keep learning and keep growing. Try and fail, but don't fail to try. Fine. As I mentioned earlier, tomorrow we are having one more session regarding digital circuit subject. In tomorrow's session, we are going to cover the expected questions and through which we are covering most of the important concept and most important concepts. Important and most important. Okay, we are covering with respect to remaining 4 chapters of digital circuit subject. So you people can attend based on your time availability. Try to attend live sessions so that you are getting maximum benefit, because whatever the queries you are having regarding those questions, whatever we are discussing, or even general you are having, you can ask in the chat. I will be replying. Okay. So I hope all of you got great learning experience with the help of today's session. So I am eagerly waiting for tomorrow's live session. So we'll meet you all at 5 o'clock sharply on tomorrow. Thank you. Thank you, everyone.